Hello students, in the series of lectures in the subject VLSI technology, today we will discuss diffusion system. So, what are diffusion systems? So basically there are three types of diffusion systems. First one is solid source diffusion system, second is liquid source diffusion system, and third one is gaseous source diffusion system. Now, what is the diffusion system? So diffusion proceeds by heat treatment of the semiconductor with which impurity species is in contact. The final goal is to achieve the doping uniformly across the surface area, consistency from the front to the rear of multiple slices, and repeatability from run to run. Now, one approach is to bring a large amount of impurity in contact with the slice by means of vapor phase transport. Okay. So, solid source technique can be used for this purpose. So, we have diffusion system. First one is solid source diffusion system. Here in this solid source diffusion system, we have a platinum source spot onto which the solid source of the impurity is placed on it. Okay. From here, carriers gas basically transport vapors from this source, okay, and deposits them on the semiconductor slices. These are the slices. The whole process is done inside a quartz diffusion tube. Source shutdown is usually accomplished by moving the dopant source to a colder region of the furnace. So if you move the dopant source into the colder region, then vapors will not be formed and source shutdown will be accomplished. Okay. In some cases, two temperature furnace is therefore needed for this purpose. Okay. Second diffusion system is called liquid source diffusion system. Here in this carrier gas is bubbled through the liquid. He is transported in vapor form to the surface of the slice. It is basically common practice to saturate this gas with the vapor so that concentration is relatively independent of the gas flow. So the surface concentration is thus set by the temperature of the bubbler and of the diffusion system. So here in this figure we can see it. In liquid source diffusion system, we have carrier gas here and we have liquid source here. So carrier gas is bubbled through the liquid source and vapors are going into this direction. These vapor consists of the liquid source, the impurities as well as the carrier gas. Here are the slices, okay, and hence here is the distributor. Third one, third diffusion system is the gaseous source diffusion system. These are even more convenient than liquid ones. So here in the gaseous source diffusion system, a provision is made from ambient carrier gas in which diffusion takes place. In addition, chemical trap is often incorporated to dispose of unreactive dopant gases. So here chemical traps are basically used. So here we can see this is the chemical trap. So unreactive components are disposed of from here. Okay. So here is the dopant gas. It is mixing with the carrier gas. Then unreacted components goes to this side and go to vent. And dopant gas plus carrier gas mixture vapor form goes in this direction and diffusion occurs in this quartz diffusion tube. Okay. So these are three diffusion systems. Okay. Another technique that can also be uh, used in addition to these is spin-on technique. So spin-on technique can be used for obtaining uniform source coverage over a slice. Here a dilute mixture of dopant compound in organosilane is used as the chemical source. The semiconductor slice is held in a vacuum chuck and rotated at a high speed. The RPM count is around 2500 to 5000 RPM. A drop of the source chemical is next applied to form a thin layer across the slice by means of centrifugal force. With appropriate attention to proper viscosity control, relatively uniform layers of the dopant can be obtained in this manner. Now, upon heat treatment above 200 degrees centigrade, organosilanes decompose into silicon dioxide, which serves as an inert matrix for the dopant. So, spin-on techniques are basically versatile. Almost any dopant for silicon or gallium arsenide can be applied in this manner. Okay. There is one side effect of this technique. The side effect is that silicon dioxide layers serve as a cap during the diffusion process. This is basically advantageous with gallium arsenide. Okay. So this is all about diffusion systems. In the next lecture, we will discuss about various diffusion sources for different type of dopants.